Let me hit record, and then I will say, welcome to the Test Wizardry. This is lesson 9, and I will share my screen. So yesterday we talked little bit about using Git, and then we started implementing some tests on Person and Wizard, and I gave an assignment to flesh those out. And I know you weren't here, Arun, but Rich, you were here. Were you able to implement any tests yourself?
I was just looking at a couple and having a think. I wasn't.
Okay.
I
I'll,
haven't
I'll
given
go
it too
through
much.
it. We'll go through it together today. So I'll jump into the source code, and like I said, I was just making a few changes. So what I'm going to do here is I'm going to, inside Eclipse, I am going to, let's see, I'm going to commit my changes, and I'm taking an awful risk because I haven't run any tests, but updates to that's good enough. Just a few changes. It shouldn't need to specify. All right. So I've got some changes that I made, and what I actually want to do is I want to go back to an older version of what I was at. So where I left off yesterday, and then we can look at the changes I make today. So what I'm going to do is I'm going to type git log, and see git log will print out the history of my commits. So you can see my most recent commit here is updates to console interface. I did that just now. Earlier this morning, I did a merge with some minor updates with these add additional tests for person, witch, and wizard. And right now you can see I'm in a detached head. What I want to do is I want to be on the main branch. So let's go back to our GitHub interface, and we've only got one branch in commit. So if you haven't checked out the code, you can go to github.com/testwizardry, testwizardry Java core, and you can grab this URL and you can clone it yourself, right? Either from the command line using a user interface or within Eclipse. But actually what I want to do is I want to go back to TestWizardry workspace. There we go, TestWizardry Java core. So now I'm in my detached state, right? So let's look at the log again. Where we left off was commit this here, commit 45 E10 78, all this. I can just grab like the first 8 characters or so, and I can copy that where I start adding tests. So that's where we left off yesterday. Let's jump back. Oh, actually, let's go to this 62C whatever, because that's where we left off, or rather, this is one correction that I made. You remember I added the expel method to school, but Hogwarts hadn't implemented expel yet. I guess this was in the days before Tom Riddle. I don't know if he was the first student expelled from Hogwarts, but we'll say he was. And so Hogwarts didn't have an expel implementation. So we added that just for fun so they could expel Tom Riddle. And you know the results from that if you've seen the movies or read the books. He became Lord Voldemort. So what we want to do is in Eclipse, we want to get back to that old state. And what I'm going to do is from the command line, I'm just going to git checkout, and then I just grab right here 62cd306. Yeah, I'm going to grab that. And now what I'm doing is I'm going back in time to my previous interface. And in Eclipse, you'll see what happened is Actually, it looks like it didn't. Oh yeah, here we go. We've got my witch test. A witch is female. We've got my wizard test. Um, and we've got all these unimplemented test methods, right? A wizard should be a muggle, or should not be a muggle, should be a magic user, should not be a muggle, should be a person, and a wizard is male. And now we don't need this can be a witch or wizard because we're adding separate tests for witch. Now you can follow along with me, but you can also see in GitHub, if you're on the main branch, you can actually go to the files here. We got source, test, Java, TestWizardry. And now you can see our wizard test. We've got a whole bunch of implemented tests here. See, here I've got Harry, Hermione, and Dudley. I created all these people. And I created tests for should be a magic user, should be a magic, or should be a person, should not be a muggle. That order is kind of a little confusing. But anyway, so that's how I implemented them. And you can see what I'm doing. I'm saying Harry is an instance of magic user. And Hermione, so Harry, a wizard, is a magic user. Hermione, a witch, is a magic user. But Dudley, a muggle, is not. So I assert false here that Dudley is not a magic user. So I thought I would go ahead and re-implement these, but I think instead I'm going to go back here, git check out the main. We'll just grab the latest here. And I've got like this detached head state. Okay. Oh, that's right. I just made changes to wizard test. So I'm going to abandon that there. And what I'll do is, yeah, let's just go ahead and re-implement them. So for our wizard test, we're going to create a wizard. And we're going to call him Harry. And he's a new wizard. And his name is Harry Potter. He is a male. Oh, we don't have to do that. Wizards are males, witches are females. So we just pass his age in. So Harry's a new wizard, right? And we've got that right here. Now that we've got it outside each method, we can use it in our methods here. So we assert that Harry is a male. We also want to, he's a hairy male. We also want to assert that Harry is a person. Now the way we do that is we use instance of, all one word like that. And what that does is it will essentially return true if he's that type, right? We know he's a wizard. Oh, I need a semicolon on the end there. We know that Harry is a wizard because we created him as a wizard. So we don't really need to test that. That's kind of a redundant test. But we also need to make sure, in case wizards, like I said, might inherit from some other mythology where a centaur or an elf or whatever can be a wizard. So what we want to do is we want to assert that Harry is a person and that Harry is a magic user, meaning he can cast spells and brew potions. Remember here, magic user is an interface. Person itself is a class, though. The difference between an interface and class, to reiterate, an interface merely describes what it can do. A class has concrete properties, values, variables, and it has the implementations of these methods. So like you can get their age, you can get their gender, and whatever is a person. Now, if you're a magic user, you're not only a person with a name and an age, you can also cast spells and brew potions. Let's go ahead and close these other things down. And so we need to see what a wizard can do. Well, a wizard implements cast spell and brew potion. In this case, all we do is return false because they're not implemented yet. So let's go ahead and document that. So a wizard is a person. It calls the super or the person constructor. Let's go back to wizard test. So Harry is a person. Harry is a magic user. Harry is not a muggle, right? So what I want to do is assert false. Harry instance of muggle. We'll just add that there. Now you can see here that closes it down, but I have these multiple imports, right? I have gender.star imports male and female. I have assert true and assert false. So I'm going to, and it looks like I got a little mixed up here in my imports. I have JUnit assert true. I just want to import assert true and assert false from org testng, this assert class. So I have both of these. Now, here we've got an interesting case. It says assert false, Harry instance of muggle. Why is that? Incomplete or incompatible conditional operator types, wizard and muggle. The reason for that is because Java type safety protects us from that. So going back to, okay, I know what I did here, different. Going back to, so Harry is an instance of muggle. Java will say, well, wait a minute, wizard, we know at compile time that wizard and muggle are incompatible. A wizard is a magic user, a muggle is not a magic user. Therefore, we don't need to write a test to check this, except in the case of if we don't know for sure that Harry's a wizard. We do know that because we're saying when we declare our variable that Harry is a wizard. But if Harry is just a person, then it can test that. And this is a more realistic scenario that we're going to implement our we're going to create our player who's going to be a person. He may or may not be a wizard. He may or may not be a witch. He may or may not be a muggle. Well, he definitely is not a witch, but she may be a witch. Anyway, so what we want is we want a person that's created as a wizard. Now, they're a muggle, or they're not a muggle, they're a magic user, they're a person, and they're male. So this is a good set of tests for wizard. And none of these should actually fail at any point unless we change the way wizards work. So let's go ahead and run our wizard tests. All right, we've got passing on all of these. Now, the great thing is that for witch tests, it's going to be almost identical, except for the last one, which is female. So witch test, we have a witch is female. And our person is not Harry, we'll use Hermione. And she's a new witch. And she's also 11. Now we need to, here, let's use our refactoring here. So what I'm going to do in Eclipse is I'm going to right click or a double click on a Mac and go to refactor. I'm going to rename this from Harry to Hermione. And you see it edits all those characters in place for each time so that I don't have to go through each different method and rewrite it. So now we have all these. Hermione is a person. Hermione is a magic user. Hermione is not a muggle. And we'll just we'll do assert true here just to double check what's going on. We don't care. We've got a wizard is male and a witch is female. But let's go ahead and run this. And we should get a couple failures here. Yeah, a wizard is male. Well, we don't actually want this test. So let's delete that one. And we'll rerun all of our tests here. All right, a witch is female. That succeeded. Apparently that only reruns the failing test. Now we have should not be a muggle. We expected true, but found false. that's kind of a contrived example. We want this to say assert false, that Hermione is a magic user. We rerun all of our tests. We've got our wizard tests. We've got our witch tests. Now let's go into our person tests, which applies both to wizards and witches. I'll click back over on Package Explorer. Person test, okay. So we have a name, should give first name when it's the first name, should give last name. We can kind of borrow this. And we'll just change this to get last name. I don't know if I showed you guys how I, oops, I changed my size there. Woo. Get back to a nice medium size there. Come on. Okay. So let's go ahead and run this and see what we've got. Okay. Oh, I forgot to add my test annotation here. We do @test, and it makes it something so that test_ng will detect that it's test. I'll rerun that. Uh-oh. So first name works. Have a name, that works. Expected Harry, but found Potter. Oh, I just didn't rewrite it. And last name should be Granger. Rerun. We're still failing. What's going on here? Expected Potter, but found Potter. Oh, there's a space before it. So let's take a look at get last name. All right, so get first name. This will introduce us to a little bit of string manipulation, right? So let's go ahead and do some string manipulation on our own. And we'll create a new package and we'll call it lesson 9. And we didn't do any of that for lesson 8, but I want to create it. Working with strings. There we go. All right. And public static void main string array args. This is just the boilerplate that every Java main class has. All right, so we want to create a string, right? And we'll call it name. Let's call it Harry, or let's give it a value, Harry Potter. All right, and we can do things like we can system out, print line, our name, and that's a good start. We'll run this. And it prints Harry Potter down below in the console here. All right, so what we want to do is we want to split this name up. So what we can do is we can do name dot, we can split it around a given regular expression. Now, a regular expression is a way to match things. You may be familiar with using like an asterisk as a wildcard. So if you were searching for everyone named Harry, you might split by Harry star or asterisk. Like when you're listing files, and that'll show you whatever. That will be a wildcard character. It says anything after this. So all my Harrys should return like that. But regular expressions are a little bit more complex than that. For instance, it says Harry dot, which means anything else, star. And now let's see what, well, let's print it. Okay, so now you can see it is an array of strings. That's what that little bracket means. So what's the length? We'll start with that. How many things are there when we split this string Harry Potter at Harry star? It says 0. Okay, so that's not a match because it includes everything. But what we want to actually do, we just want to split it on the space, right? And there are 2 values here. So if we split it here, and what we'll do, we'll create an array of names. Well, not the length. So what we're doing is we're creating an array. Actually, that goes here by convention. It'll be fine in either spot. So we're splitting our name in half based on a space. And then what we want to do is we want to do for and now colon means in this case, for string n in names. So it's going to give me a list of each name in names that was split up, and then we'll just print them here. We run this again. Okay, so we see here, we print the full name the first time, and then we print Harry, and then we print Potter. So that's working. But what if Harry has a middle initial? That's going to work fine. Except, how do we know if, well, I guess in the normal situation, that's going to work. But I'm trying to, the one example I thought of, just thinking, Oscar de la Hoya, which is a name, that de la Hoya is actually the last name. So what we could do is we could split this in a maximum number of 2, I believe. That's how it works. And then it would say Oscar is the first name and De La Hoya is the last name. But what if we had, what if we had someone whose name was John St. James? Now, St. James is his last name and John is his first name. That works. But what if his middle name is, I don't know, Richard? I'm making up names here. Well, now we've got Richard St. James. So just splitting it on the space, what I'm trying to show, is not a good way of figuring out the last name. Let's take a look what we've done so far in the person implementation. So get first name says everything up to the first space is the first name. Well, that's not necessarily true because someone might have 2 first names. They might go by, like a French person might go by Jean-Paul. But this is how I did it. So first name, index. So what I want to show is index of and character at. So split is the first way we can implement that. Let's go ahead and go back to Harry Potter for now. All right, so we're getting first name and last name. Now, another way we could do this is we could do name character at, and now it's looking for the index. We want the index of the space. So we can say index of space and let's see what this says. This now 5. That's because what it's doing is it's taking Harry and it's saying that this space is at 5. And the way we get that is 0, 1, 2, 3, 4, and then 5 because it starts with 0. So we could say, well, let me go. End of first name equals name index of space. Now we have index of, and it takes a string or a character. We also have last index of. And we could do that for the other one. And then we can system out print line name substring. Now we want to start at 0 at the beginning, and then we want to go up to the end of first name. We run that and we see we get Harry. And I don't know, it looks like we include the space on the end there. Let's add a character at the end here just to test if we're including the space. Harry period. So okay, we're not including the space. Now let's try the same thing with last name. System out name substring. Now what we want to actually start with is we want to start with not end of last name, start of last name. So that's the beginning, right? We want to start here at the P, and then we want to go to name.length. Which doesn't have parentheses as a quote. Oh, I want start of last name. Feel free to interrupt me, guys, when I'm making a stupid mistake here. Oh, we do want parentheses on length. All right. It is a function. All right, we've got a space before, and I went through this to show that my implementation on person is actually doing this. It's doing it kind of the hard way. So get first name, we look for the index of the first space character, and then, well, this is another trick that we run into. If they don't have a space, then because index of will return -1. And the same thing for last name. This is where my error is happening. It's starting with the index of. So what we actually want is the index of last name +1. And then substring can optionally take just a beginning index, and it will include everything after that point, including it after. So in my person, if I return index of last name +1, and actually we should probably just do that here. It's better to keep your logic and your implementation separate. So this is where we're doing logic. This is where we're just getting the value. All right. So let's go back to our person test, run all this again. And now should give last name is working. Now, maybe it's easier to just split it up, right? To do, because we've got the same problems here, like people with multiple first names or multiple last names or middle names can still, well, I guess we're taking care of the middle name issue here by getting only the first and last with the space. I think we'll just have to live with this for today since we spent a lot of time on string interpolation. But what I wanted to show you is, so strings, you can split a string, you can get the index of a string, and you can actually, we can find out the location of a single character, which is the character at. For instance, we can find the P. And what this will return is, I believe that'll be 6, right? Oh, wait. Let's see what character at says. Oh, character at takes the index. So So if we get the character at 6, it should return the P. There we go. So we've got character at and index of. These are like the low-lying or the low-level implementations. You can find a character at position 6 in a string. You're treating a string as an array of characters. Index of, so this is saying find me in string the number where the space is. Whereas this is saying give me the letter at this index. So char at or char at, character at, index of are kind of opposites. I'm curious, is there like a last character at? Oh no, because it's specifying the variable or the position. So this returns the P at 6. This would return 5. So I actually want last index plus 1, or that's going to return 6, and so forth. All right. So that's showing you how to manipulate string. There's a whole bunch of string manipulation techniques. I just wanted to expose that strings have a lot of built-in functionality, so you can get down into the nitty-gritty of splitting them up. You can see I've also done some weird stuff here in person where I give you the option to capitalize the name, and what it does is it just it gets a substring. So at the substring 0, 1, in other words, the first character, it uppercases it, and at the substring 1 until the end, so everything else, it uppercases the first letter, and then it lowercases everything else. So that's what this capitalize does on person. It really doesn't make sense to do this capitalize method in the person object, but I didn't have anywhere else to put it for demonstration. Now, I have this a or an, which is kind of, I'm baking some English grammar into the person object, which is a terrible idea. But like I said, I didn't have anywhere else to hang this information. But what I wanted to do was I wanted to implement this, where is it? The toString methods, right? So it says Harry is an 11-year-old wizard, or Hermione is an 11-year-old witch, or Dudley is a 12-year-old muggle, etc. So a or an, there's two ways that I implement a or an. If it is spelled out, I just say, if it starts with a, e, I, or o, or u, which isn't always the case. For instance, you would say is a 1-year-old instead of is an 1-year-old. But English is a language full of contradictions and breaking its own rules. But in general, here's my naive attempt, a or an. If it starts with a vowel, you use an. This is encoding English grammar into the person object, which is, like I said, a terrible idea. Otherwise, return a. Harry is a wizard. Hermione is an octopus. I don't think so, but whatever. Legolas is an elf. That would work. Or if it's a number, right? So if the number is 8 or 11, and I couldn't think of any other examples, right? So Harry is a 1-year-old, not Harry is an 1-year-old, but Harry is an 8-year-old, or Harry is an 11-year-old, or is an 80-year-old. So we're getting the character at 0. This is stuff that needs to move out of the person class, but I did it just for demonstrating string manipulation, and so that when we can print a person, it will say that person is, Harry is an 11-year-old wizard. All right, back to our tests. So we've got our person tests, and Let's see, it should have first name, last name. That's working. And then let me peek at what I've implemented over here. So I'm looking in GitHub to see what I did previously. So let's look at our person test. All right, should have name, first name, last name, and I actually had that bug identified to demonstrate today. All right, you should be able to change your age, and you should have an age. Let's go ahead and grab these, and we'll grab gender too, just to speed things up. So I'm just going to paste these tests into person. All right. Oh, and I added some more people up here. I guess I just added one, Albus Dumbledore, to test a different age. All right, so let's look at should have age. I've got some problem here. Assert static for assert equals. Oh, that was the other thing I did. So in order to make it clear, I want to import static assert dot star. So I can have assert equals, assert true, assert false, etc. And now I can just make this clearer to read, because being able to read your code makes it easier to understand. The closer it sounds to real English. Oops. We're going through assert equals. Okay. We save that. Okay, all of our tests here. Okay, we have an age. We assert that Harry is 11 and Dumbledore is 99. We'll comment out these other tests and we'll run all. Okay, everything looks good. Have first name, have last name, have age, have name. All right, so let's go ahead. We want to also be able that someone can change their age, right? So we're doing Harry, set age to 12. And all it does is it takes your age as a parameter. It's an integer. And it uses this age as age. So we've got a bit of a name collision. We've got age that's scoped only to this set age method. And we've got age that's in common to the class. So by referring to this dot age, it means the age for this instance of person, not the age passed in the method. It's kind of a sloppy way of doing it, but it works. So let's go ahead and run our person tests again. We'll go ahead and run all our tests. Should have age fails. Now, why did that fail? It says expected 11, but found 12. Let's see, should be able to change age. That succeeded. But it turns out that, that it ran change age first. So it violated our expected conditions. That's a consequence of having this at our class level. So what I want to show is we don't want to set these at the class level. We want them to be accessible, but we want to set the values before each test. So what I'm going to use before method. This is a test-ng annotation. I'm going to just create a method called setup. And what this is going to do is it's going to, for each method, in other words, before should have name, should give first name, before all of these, it's going to set those values automatically. Or it's going to run this before method every time. So I'm going to do Hermione and Albus. We could do this in each individual method. In other words, if I created we can even start as age at something else, right? Now, when we run this one, oh, I've still got errors from up above. I'll fix those. I need to import this. All right, so we imported before method there. We'll save it and we'll run all of our tests. Now we're all succeeding. Now, alternately, I've got Harry here, Harry Potter. That's again at the class level, kind of like, so at, if I did this dot Harry, it's actually going to, you'll see it'll fail in a different way. Now it's saying, take the Harry that belongs to the whole class and change his age to 12. Well, this Harry Smith is only 9, and that's why he failed. Expected 12, but found 9. But what we want to do instead, what we could do, we could just ignore the global Harry, and that's probably a good thing to do in this case. But because we're setting this before each method now, so it doesn't matter whether it runs should have age or should be able to change age first, that before both of those classes, it's going to reset his age to 11 and all the other ones as well. So we can go ahead and run this now. Should be able to change age, fails, expected 12, but found 11. Oh, because we never set it. So we can do Harry set age as 12. He's a second year. All right, so now we have all of our tests succeeding for person. We have person tests, we have wizard tests, we have witch tests. We can even go ahead and add a muggle test. And muggle test is going to look a lot like a witch or wizard test, except it's going to fail differently. Where did muggle test go? Here it is. So I'm just going to cut and paste all this in here, and I should change all, well, I don't want Hermione. So I'm going to create a muggle. I'm going to call it Hermione here for an instance. But I'm actually going to create Dudley. Dudley Dursley. Dursley. He's male, and he's, I think he's a year older than Harry. Clean up my imports. And what I want to do is I named it Hermione just so I can go back here to refactor, rename Dudley. And now it's changed in all of these other methods. Okay, so a muggle should be a person, etc. Let's run this test. Oh, well, this one, we want to get rid of that one. Oh, are witch tests failing? Oh, interesting. If we run Hermione is a muggle, oh, we've got errors. So it didn't actually, we can eliminate this one. So we had that error, so it didn't compile, and it ran it when it was directly cut and pasted from witch. All right, so let's rerun our muggle test. All right, so now should be a magic user. This does not look right at all. Oh, Dudley is not a magic user. Yes, that's right. Dudley is a person. That's true. Should not be a muggle. Okay, so my name here is wrong, not my test. All right, a muggle should be a muggle, should be a person, should not be a magic user. Those are all working okay. Now I am suspicious. I don't understand. Like, it should not be a muggle is assert false and assert true. All right, maybe I changed those and I don't remember. If you guys saw me change those, that's fine. Otherwise, maybe through the magic of cut and paste. So we've got all these tests. Next thing we want to do, we've got all these tests working. Let's eliminate this new test, which is not interesting. That was just to show the basics of TestNG. So we've got all these tests. Let's go ahead and run all of our tests. All right, so we've got a whole slew of tests. Some of them failed. What do we got? Oh, we've got our which test, should be a magic user. Okay, so that's what I was tripping about, is that this was wrong. Let's see, should not be a muggle. Assert false. I feel like I'm in the Twilight Zone here. And we can rerun our tests. Those are all succeeding. Good. And then we'll go here and we'll rerun all tests. All right, so we've got all of our tests. That's great. So there's one more thing I wanted to do, and that is to finish up our acceptance to Hogwarts. So I want to go to TestWizardry console. Oh, I'm in test. It's one of those days. I'm having trouble thinking straight. So I'm just going to show you what I've done here. There we go, console. All right, in TestWizardry console. So we have it here. Actually, I haven't implemented that. That's right. I started from the older checkout, but I have it under intro, which is a different version. So what we want to do is we want to say here we want to create our wizard or witch, and remember we're doing that up above in create. So I guess really we just want this new acceptance letter. And let me show you the acceptance letter in a minute. So there's a couple of things we need to change about this from my initial implementation. Acceptance letter takes a wizard. Well, it takes a witch or a wizard. So it takes a person. And then takes the player. And I will show you what's going on. So we'll change this to person 2. So we pass the player into the acceptance letter, and we load this file. I'll show you how to do that in a minute, and then we print out the letter, player last name. All right. So I've got these 2 different TestWizardry consoles. This is my first take that I implemented myself. I also wanted to add a couple of nice things here, like so rather than just asking the age and gender, what we'll go is we'll say, tell me a bit about yourself, and we're going to say hello to the people when we meet them. So we ask them the name and we say hello, and rather than asking, let's move this down below. What is your name?
And you are having name, so just changing the first name to name should work.
Yeah, but we want to be able to accept first name or the whole name. So we want to print the acceptance letter. And I think I want to also use this friendlier message. Thanks for playing, but you're not eligible for Hogwarts. And then it will actually exit and, in other words, end the program. Okay, now it's school instead of to attend. And then what we want to do is I want to change this to where's school. We want to move this. Yeah, school Hogwarts. So we want to do school get name because multiple schools could be used in this. There's other magic schools that we might implement. There's one in France, I think. So that was another thing I did is we need our interface school to include a way to get the name. And then we need Hogwarts to know how to get the name. So it's going to say add unimplemented methods and get name. We just want to return name. Hogwarts School of Witchcraft and Wizardry. All right. That should be working, right? Public stream, but we don't want overrides. That's where Eclipse is a little overzealous. So name equals string name, return name, public string get name.
You got the school as Hogwarts, not school.
What's that? Oh,
You got the,
yeah, okay. So we can either change that. Thank you guys. You're teaching me how to program. And our acceptance letter, it should take a person. Change constructor acceptance letter person to acceptance letter person. That has me baffled. I know what might be going on here. Yep, I imported the wrong acceptance letter out of the intro. Okay, and now what I can do is I can actually delete everything in this intro. All right. And we're not actually using magic user here, so we can clean that out. Okay, so let's go ahead and run this one more time and see how we're doing. I'll expand it so it's full screen. What is your name? My name is Aaron Evans. Are you male or female? I'm a male. How old are you? I'm too old. That's too old for Hogwarts. Are you sure? Yeah, I'm sure I'm 45. Okay, Aaron is a 45-year-old wizard. Thanks for playing, but I'm afraid you're not eligible to attend Hogwarts school. And that ends. Okay, that works. All right, let's try Harry Potter. Hello, Harry. Tell me a bit about yourself. Are you male? How old are you? 11. Harry is an 11-year-old wizard. Congratulations, you've been admitted to Hogwarts. Dear Mr. Ms. Harry. It would use the last name if there was one. We are pleased to inform you, etc., etc. Let's try another one. We'll try Hermione. What is your name? Hermione Granger. Female. I'll misspell that. Okay. Exception. We need to handle that exception, but we're not going to handle that yet today. Female. It's that exception was because I misspelled female, and gender is an enum, which the value has to match exactly. You're a witch. How old are you? 11. All right. Hermione is an 11-year-old witch. Congratulations. You've been admitted to Hogwarts. Dear Mr. Ms. Granger, etc. It's off to Diagon Alley. So that would be our next step. We'll do one more. What is your name? My name is Dudley Dursley. Are you male or female? I'm male. You're a wizard. How old are you? 11. Well, that worked. So we don't really have any way within our game for Muggle. We have the logic, but the game, we have the logic in our program to reject Muggles, but you can see in our system, it always creates a new wizard or witch. Where is it at in, nope, not here in gender. Oh, here, player equals create player, which it just assumes you're a wizard or a witch. So we're going to leave that for now. The last thing we wanted to do is ask gender. If gender is male, otherwise, if gender is female, print you're a witch. What we want to do is we want to check this by using a try catch block. I wanted to introduce exceptions. And rather than go through that, we'll go through that tomorrow. And we'll talk a little bit about exceptions tomorrow, as well as round this out. And then that'll be the end of this 2-week course tomorrow. And then starting back up in November, we will implement a web interface where it'll essentially have a few pages where you do the same thing. It'll create a web form that asks you this information. It will then use this same implementation we've checked, you know, are you a witch or a wizard? Are you a magic user or not? Are you the right age? And then we'll get the Hogwarts acceptance letter. We'll build, I think it's going to be 3 pages, I determined, and we will use Selenium to test that. Anyway, that's it for today. Thanks, everyone. I'll go ahead and stop sharing and stop.